Hello students. So I have to make a video so that you can understand graphing a little bit more, including finding some points of discontinuity or holes. So the holes are going to occur when something cancels in the equation. So we're going to take a look at that. The first page of these notes, we're going to pretty much skip for the video. I'll come back, I'll circle back and talk about it. It's actually kind of fun. It's like find as many horizontal asymptotes as you can in 2 minutes. And then same thing with horizontal and vertical asymptotes. You should end up getting pretty quick at finding these. But we're going to skip that for now. And I do go through like how to actually find a point of discontinuity in this first example. But I think that it's more worth our time to just dive into a graph. And I'm going to try to do 3 graphs with you. So I will be talking quickly, but that's the beauty of a video. You can pause, you can rewind, you can rewatch. So make sure you do that. All right, so the first graph in these notes actually does not have a hole. So we don't need to do that one. We're going to skip that one as well. So we're actually going to start with this example number 2. The very first thing you should do for these problems is factor them immediately because you want to see if something ends up canceling. So as you can see, I already did that. I took this trinomial. I found 2 numbers that multiplied to -3 that add to +2. And I used those numbers, +3 and -1, to factor. So when that happens, I get x plus 3 and x minus 1, and I have that x minus 1 on top. So it's pretty clear that we are going to have something cancel. So the x minus 1's cancel. And for these problems, when I cancel out, I actually like to cancel and draw an arrow. So just like I did this, because this is going to actually tell us something, but I'm going to actually put a pause in that part of it until the last step. So you want to recognize something canceled. That means there's going to be a hole. But before we talk about the hole, I want to write out the simplified fraction. So if you can think back to semester 1, we simplified problems like this. So after you cancel, there's nothing left on top. So this is what we have to write, simplified. I like to kind of label, this is the simplified fraction. There's nothing left on top, so I put a 1, and that's going to be over x plus 3. So from here on out, the rest of this problem, I am graphing based off of the simplified equation. I am not graphing based on this original at all. Okay, so it's almost like we're going to ignore it. And then we're going to go through and find all of the things. So starting with our vertical asymptote, and it's the vertical asymptote of this. Okay, so use that. Vertical asymptote is when the bottom equals 0. So if x plus 3 equals 0, I subtract the 3 over, and that gives me the equation of my vertical asymptote at x equals -3. For the horizontal asymptote, I have to compare the top degree to the bottom. In this example, the degree is larger on the bottom because it's x to the first on the bottom, and there is no x on top. So it's a bobo, which means it's an automatic y equals 0. Moving on to the x-intercept, again, still off of the simplified. Totally ignore the original, because if you look back at the original, guess what? You're going to get the wrong x-intercept. All right, so you have to go from the simplified equation. Now, if I set the top equal to 0, which is what you do, you get a false statement. So if that happens and you get a false statement, that just means there is no x-intercept, so that one's none. Moving on to the y-intercept. The y-intercept is when we compare the constants. So the constants are the numbers that don't have any variables with them. So on top we have a 1, on the bottom we have a 3, which means the y-intercept is 1/3, 1/3. We'll write it as an ordered pair. And so far, this is really no different than the graphs we did yesterday. Here's the new part. Now we have to go back and find where is that point of discontinuity, or where is that hole. So we have to do 2 steps to find the hole. We need to identify the x value, and then we need to find the y value. So to identify the x value, you actually go back to this canceled factor. Whatever that matching factor is that canceled out, you want to set it equal to 0 and solve, kind of like a vertical asymptote. So at x equals 1, at x equals positive 1, because I just added that 1 over to the other side, there is a hole. So then we have to find the y value of the hole. To find the y value, you plug in, but you make sure that you plug in to the simplified function. If you plug into the original, you're going to get a 0 on the bottom. So you have to plug into the simplified equation, which is 1 over x plus 3. So I'm going to plug in 1 for x, which is 1 over 4. So the point of discontinuity, the x value was positive 1, and the y value was 1/4. So now it's time to put all of this on a graph. I actually already started by drawing the vertical asymptote at -3. And so now I'm going to draw the horizontal asymptote, which is at 0. This was a bobo. Next, I am going to draw the y-intercept. There was no x-intercept, so I'm skipping a y-intercept at 1/3, which is just somewhere in between 0 and 1. And then the point of discontinuity is almost like it's another point for us. So it's kind of nice because it provides another point. Now, the point of discontinuity is a hole. So you have to draw it as an open circle because technically the function is undefined at x equals 1, okay? But it's not undefined where it's a vertical asymptote, it's undefined as a hole. So they're just different types of discontinuities. The vertical asymptote is called an infinite discontinuity, where the graph approaches it. A hole is a point of discontinuity, where it's just that singular hole. And again, the reason it's a hole and not an asymptote is because on top, that factor canceled with something on the bottom. So it just looks different in that case. But this is enough information to say that the graph is in this corner. So you kind of have to do like 2 parts to the graph if you're going to be like crazy like me and make all of these look really nice. This part's kind of annoying because it's like going to look kind of be linear, but that's okay because it just approaches the x-axis anyway, and then this one goes up forever. So it's not perfect, but good enough. Now I have to figure out if the rest of the graph is up here or down here, so I do have to find that additional point. And that'll be our last step. So I'd like to pick the point closest to the asymptote, so I'm going to find f of -4. And you guessed it, plug into the simplified. The simplified function is the function you are graphing. So just depend on that, okay? So 1 over -4 plus 3 is 1 over -1, which is -1. So the point is x is -4 when y is -1, which is this point right here. And that is all I needed to know so that I could know that the graph is on this corner. And that is it. Beautiful. So it's very similar to the problems we did yesterday with the addition of just graphing that hole. We're going to do it again because sometimes things get weird, and it happens in number 3. So I want you guys to look carefully at number 3. If you look careful, it's literally the equation we just did, but the reciprocal. It is flipped. How does that make it different? Well, it actually totally changes everything, okay? Not to be dramatic, but it's a game changer, literally. So, again, if you just kind of glance at this, you may be thinking to yourself, I know you're thinking this, but Mrs. Scott, we haven't done problems where the degree is larger on the top. That's in slanted asymptote. You said we're not doing that yet. Correct. This is a red flag that something is weird about this problem. It's either going to be a slanted asymptote or it's going to be something that has a hole. And so let's see what happens when we factor. It's the same problem as above. It's just that now this is on top. So x plus 3 and x minus 1. And then x minus 1 is now on the bottom. So we still cancel, and there is still a hole. But the weird part is the simplified, because what is the simplified equation? Well, okay, it's x plus 3, but it's over 1. So what do we do. Do you guys agree that like 5 over 1 is just 5 and 10 over 1 is just 10? So x plus 3 over 1 is literally just the equation x plus 3. But that's not a rational function. There is no vertical asymptote. If I set the bottom equal to 0, it doesn't, that's not true. That's a false statement. The horizontal asymptote, well, we don't know how to do it when the degree is bigger on top. So I'm also stumped. Here's the deal. This is a special situation. So when I factor and I cancel and the leftover piece is on the top and there is nothing left on the bottom, therefore a 1, what we actually have is no longer a rational function. It's actually a line, like linear equation, like y equals mx plus b. It is a line and it has a hole. So what? I mean, literally, now we're going to graph y equals mx plus b. There's not going to be a vertical asymptote. There's not going to be a horizontal asymptote. Why not? Because it's a line. Okay. And so now what's the x-intercept? We can still do this. The x-intercept, you still can set the top equal to 0. So it is actually going to be -3. The y-intercept is the constants, so 3 over 1 is just 3. And we'll come back to the point of discontinuity. So, oh, actually, let's do it. Let's do it now. So the point of discontinuity is going to happen. The hole is going to be at x equals 1. So then I just plug into the simplified. 1 plus 3 is 4. So the point of discontinuity is at 1 comma 4. All right. So when I say this is y equals mx plus b, I'm not kidding. The slope of this line is going to be 1, and the y-intercept is going to be 3. So, which, by the way, we found here too. So y equals 3, slope of 1. But wait, uh-oh, I messed that up. Up 1, right 1, up 1, right 1, up 1, right 1. I messed that up because I almost forgot. I have to graph this hole. 1 comma 4 should be an open circle. So there still is a hole. This is going to be a line with a hole. And notice that the x-intercept is at -3, which is where I wanted it to be. Okay, so make sure that when you do this, you graph the line, but you also graph the hole. So this is no longer a rational function. All right, so let's rewind and summarize, and then we'll do one more problem together to hit it home. All right. Rewind. So, summary. These two were the exact same problems, just flipped, literally reciprocals, and they look completely different. Moral of the story is this. When things cancel and I'm left over with something on the bottom, it's still a rational function. We still do all the things, but we do it with the simplified version, okay? The simplified version. So, something cancels. I'm left with something on the bottom. We still do all the things with the simplified equation, but don't forget to graph the hole, okay? If something cancels and I'm left with something on the top and nothing on the bottom, well, then it's a line with a hole. So we just can do y equals mx plus b, but make sure you find the location of the hole and you graph it. Okay, so that is the difference. All right, now let's do number 4. It does say you try, but let's try it together. I'll go nice and quick through this. Hopefully you're like, oh my goodness, this makes so much sense. Here it is. Top factors to x plus 2x plus 1. All right, bottom factors. X minus 3. X plus 2. All right, so something, I wrote x plus 1. I knew something looked weird. Okay, sorry, it is x plus 2. That's what it factors to. My bad. All right, so something does cancel, and it's the x plus 2's. We'll come back to that. The simplified graph is going to be x plus 1 over x minus 3. This is what I will graph. So vertical asymptote is x equals 3. I'm going quickly through this. Bottom equals 0. Horizontal, the degrees are the same, so the coefficients are 1 over 1, which is 1. X-intercept, top equals 0, so -1. Y-intercept, compare the constants, so -1/3. Point of discontinuity is the whole. Go back to the canceled part. So the whole is at x equals -2, okay? I set the canceled factor equal to 0. I solved. I plug into the simplified to find the y. So we have -2 plus 1 over -2 minus 3. We're not afraid of fractions here. We will not be afraid of fractions. -1 over -5 reduces, or the negatives cancel, to +1/5. So the whole is occurring at -2, +1/5. Let's put it all on the graph and call it a day. This is fun. Okay, so we have x equals +3. We have y equals 1. We have a y, or an x-intercept rather, at -1. Change that to solid, at -1. We have a y-intercept at -1/3. And at -2 1/5, we have the whole. So that only helped us with this side of the graph, which is fine. And so now I have to find one extra point and we will be done. So I'm going to find f of 4. And I'm going to find it in the simplified. So that's 4 plus 1 over 4 minus 3. 5 over 1. So the point is 4, 5. 4, 5 up here. You may be wondering if the graphs are always like kitty corner from each other like this. Very often the answer is yes, but there are exceptions. So you always want to find that extra point just in case this happens to be one of those graphs where it's not across from each other like this. But that's it. So I hope that that made a lot of sense. This last time we went through it quickly, like, oh, this makes sense. We factor. If we can cancel, we do. We write the simplified. We find all the info based on the simplified. We go back and find the location of the whole, and we plot, 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 and have a good time. So hopefully this made a lot of sense. If not, go back, rewatch, look at my answer key on my notes, do it that way. Good luck, and peace out. Have a good weekend.